Welcome to my channel. Today we look at some questions and answers in linear algebra. If you've not subscribed to my channel, remember to subscribe so that whenever I upload lessons, you can easily see them. Let us start with this first question. Now, this question says, consider the following system of equations. So the system of equations has been given to us: 3x plus y minus 2z is 7, 2x minus 3y plus 5z is 18. And then it proceeds and says that use Gaussian elimination to put the augmented coefficient matrix in row echelon. Obtain this, that the result will be this: 1, negative 1, 1a, row 2, 0, negative 1, 3b, and then row 3, 0, 0, 7 is c. Find the value of a, b, and c. And then after find the value of a, b, and c, solve this by back substitution from the last equation here going up to find the values of x, y, and z. Now, so this question wants to see whether you know how to use elementary row operations elimination. Whether you know that to solve a system by Gaussian elimination, you want to create one in this position by either dividing this by 3, or sometimes you can even interchange the rows. Interchange the rows, add a multiple of a row to another row, and so on. So those are the techniques that this question wants to find out whether the learner knows how to use them. Now, let's just look at the augmented matrix. The augmented matrix is 3, 1, negative 2, 1, and then we have 4, 0, negative 1, 7, then we have 2, negative 3, 5, and 18. This is the augmented matrix. And it's this matrix that the question is telling us to reduce to echelon form and obtain this. So we'll be playing with these numbers and with elementary row operations by either interchanging the rows, or adding a multiple of a row to another one, or by dividing a row by a given constant until we obtain this. Once we've obtained this, we shall read the values of a, b, and c to be the solutions here, and then use them to solve for x, y, and z. Now, so what this result here demands of us is to have a 1 in this position. This position here, we must have a 1. So there are various ways of obtaining a 1 here. The first option may be to divide this first row by 3. And look at what you obtain when you divide by 3. When you divide by 3, there'll be 1 here, yes. But what about this? There'll be 1 over 3. That is not what we want. What we want is negative 1. If you divide by 3, there'll be negative 2 out of 3 in this position, but what we want is 1. So that means that the option of dividing this first row by 3 may not work for this particular question. So we think of another option. We think of another way of obtaining 1 in that position. So we now think of maybe adding a row to another row, or subtracting a row from first row. For instance, if I was to subtract row 2 from row 3, no, from row 2 from row 1, if I were to subtract row 2 from row 1, what would be the new row 1? The new row 1 is 3 minus 4 would give us negative 1. And then 1 minus 0 would give us 1. And then negative 2 minus 1 would give us negative 1. Then 1 minus 7 give us negative 6. So you can see this is working, because the next thing I may want to do now is to multiply the entire row by negative 1. So when I multiply the entire row by negative 1, then this will become 1, this will become negative 1, this will become 1, and this will become 6. And that is what I want to achieve. That's what I want to achieve. So that would be a very easy way, one of the ways of doing that. This would be one of the ways of doing that, obtaining the first row the way it's required. And then there is another way. interchange row 1 and row 2. That is the way that I want to use. So let me just go to the solution. Let me now do the question, and I want to use that second option. Now, so what the question is saying, therefore, look for the best way to work out so that you have the row echelon matrix that we've been given. Now, so what is the augmented matrix? Let me just write. The augmented matrix is 3, 1, -2. What was it? 3, 1, -2, 1. And then we have 4, 0, -1, 7. And then we have 2, -3, 5, 18. This is the augmented matrix. And what are we supposed to achieve? Let me just write what we're supposed to achieve here, so that as we begin, we know what we are looking for. We're supposed to achieve 1, -1, 1, R, and then 0, -1, 3, B, then 0, 0, 7, C. So this is what we're supposed to achieve. So we want to work out this matrix until we obtain this other matrix that we've been given. So I will say that the first thing I want to do is to interchange row 1 and row 2. Let me interchange row 1 and row 2. And when that happens, my row 1 now becomes 4, 0, -1, 7. And row 2 is 3, 1, -2, 1. Then row 3 is 2, -3, 5, 18. So this is what I now have. Now, let me now subtract row 2 from row 3. No, row 2 from row 1. So my new row 1, I want it to be the difference between the current row 1 minus row 2. Now, so 3 from 4 will be 1. 1 from 0 will be -1. -2 from -1 will be 1. And then 1 from 7 will be 6. So you can see again that has given us what we want in the first row. Now, so the second row remains the way it is, which is 3, 1, -2, 1. And the third row remains the way it is, and that is 5, 18. Now, so my second step now is to obtain a 0 in this position and a 0 in this position, because that is what this question is telling me, that I must get 2 zeros here. So I'm using this one that I've created in that position. So that is, let me write my step here. I'm saying that I want a 0 in that position. So my row 2 should now be the current row 2 minus 3 row 1. And then my row 3 should now be the current row 3 minus 2 row 1. So that means, therefore, that row 1 remains where it is. Row 1 remains where it is. So let me multiply this row 1 by 3 and subtract from row 2. So 1 times 3 will be 3, from 3 will be 0. And then this times 3 will be -3. From this, I'll have 4. And then 3 times this will be 3. From -2, I'll have -5. And then this by 3 will be 18. 18 from this, I'll have -17. Now, multiply equation row 1 by 2 and subtract from row 3. So this by 2 will be 2, from 2 you get 0. And then this by 2 will be -2. -2 subtracted from -3, you get -1. And then 2 times 1 will be 2, from 5 you have a 3. And this by 2 will be 12. 12 from 18, that would be 6. Now, so what is the next thing that we want to achieve? -1 in this second row, second column position. But what I have is 4. So the option is maybe we may divide the equation row 2 by 4. But when you divide row 2 by 4, what do you get? You get 1 in this position. And in this position, you get -5 out of 4. And that is not what we want. What we want is 3. That means the option of dividing row 2 by 4 will not work for this question. What is that option? That option is to interchange equation row 2 and 3. And that is what I take. Interchange row 2 and row 3. That is what I use in this question. So as I said at the beginning, this question just wants to see whether you can use the elementary row operations. And there are several elementary row operations and you know them. So when I interchange row 2 and row 3, then row 1 remains the way it is. Row 1 remains the way it is. So row 2 now becomes -1, 3, 6. And row 3 becomes 0, 4, -5, -17. So the first row now is in the format that is required by the question. The second row also is in the format that is required by the question. Now let's come to the third equation and create a 0 in this position. So to create a 0 in that position, so I'm looking for the new row 3. And how do I achieve that? By taking the current row 3 plus 4 row 2. So when that happens, the first row remains the way it is. The second row remains the way it is. Now the third row, this times 4 plus 0 would give us the. Now the second row has a 0 here. Has a 0 there. Now, so 1 times 4 plus 0 will be 0. Which one? Not 1. I'm multiplying equation 2. Equation 2 by 4. So it is 0 times 4. It is 0 times 4. Not 1. It's 0 times 4 plus 0, which is 0. And then -1 times 4 plus this 4, which gives us 0. And then 3 times 4, which is 12, plus -5. That gives me 7. And then 4 times 6, which is 24, plus -17. And that gives me 7. So now I have what I wanted to achieve. Because I wanted to achieve 1, -1, 1, A. So my A is 6. My A is 6. I also wanted to achieve 0, -1, 3, B. So my B is 6. I also want to achieve 0, 0, 7, C. 0, 0, 7, C. So my C is 7. My C is 7. So then the question says that once you've gotten A, B, and C, now find the values of X, Y, and Z. So I just come back here using this matrix here. This is X minus Y plus, so what I have there is X minus Y plus Z is 6. In the second equation here, I have -Y plus 3Z is 6. And then this last one I have 7Y is equals to 7. Now we solve from the bottom going up. The last equation here implies that Y is, no, this is Z. This is Z. This is 0x plus 0y plus 7z. So this is Z. So that means that the last equation implies that Z is 1. Z is 1. So now I come to this second equation, and where there is Z, I write 1. So this will be negative 1 plus 3 times 1 is equals to 6. That means negative 1, if I took this 3 the other side, it will be negative 1 is 3. Negative y is 3. Which means that y will be negative 3. Now come to this first equation where there is y put negative 3. So that negative 3 and this negative becomes positive. And where there is z put 1. So this is 3 plus 1, which is 4. Take for the other side of the equal sign, and x becomes 2. And that is what this question wanted. The question wanted you first of all to reduce this matrix to echelon form, and after reducing to echelon form, find the values of A, B, and C, which we found to be 6, 6, and 7. And then after find the values of A, B, and C, find the values of x, y, and z. And so just using this matrix to find the values of A, x, y, and z. Now, so let's look at the next question. This is our second equation and says that consider the following system of equations. X minus y minus 3z is 3. 2x plus 0y plus z is 0. And 2y plus 7z is c. Now, so the question is, for what values of c does this system have infinitely many solutions? And b, for what values of c does this system have no solution? And this is a very good question for us. We have a video that there's a lesson that I uploaded on the YouTube on how to determine if a system has infinitely many solutions or no solution or a unique solution. So you may also find time to look for that video and then get more knowledge on how to answer this type of questions. But let me answer this question. So that means we must extract the augmented matrix and then reduce to echelon form and look at the last equation, the last row, to tell us more about the type of solutions that we can get from this system. So let me just write the augmented matrix. So the augmented matrix there is 1, negative 1. Let me just be sure that I'm writing the exact thing. Negative 3. And then I have 3. I have 2 here. 0x and then 1z is 0. Then lastly I have 0, 2, and 7. Then c. Let me reduce this to echelon form. I want a 0 in this position. That means the new row 2 that I want, I should obtain by taking the current row 2 minus 2 row 1. So when that happens, then row 1 remains the way it is. Now you can put this vertical line to separate the constants from these coefficients, or sometimes you can just avoid, you can leave putting that vertical line and you still have the same result so long as you know what the constants are. Now, so this times 2 from this gives us 0. This times 2 from this gives us 2. This times 2 is negative 6. From this is 7. Yeah, because it will be 1 minus 6, which is 7. And this would be 0 minus 2. Now, so this times 2 will be 6, from this will be negative 6. Now, the second equation, the third one remains where it is. The third one remains where it is. Now, so I want this one to be to use this one to create a 0 in this position, so that means that I need to get the new row 3, I need the current row 3 minus the current row 2. So when that happens, then I have 1, negative 1, negative 3, then 3. I have 0, 2, 7, negative 6, and then here I would have 0, 0, 0 is C. Now I'm subtracting row 2 from row 3, so this minus that, so this would be C plus 6. This will be C plus 6, and I subtract that. Now, so the question is, therefore, we've already reduced to echelon form. This is the echelon form. So the question is, what should be C so that this system that we're given will have infinitely many solutions? Now, for it to have infinitely many solutions, then we want 0, 0, 0 on the left side, and then 0 on the right side. So that means then C plus 6 should be 0. In other words, C should be negative 6. So if C is negative 6, then this system that we're given would have infinitely many solutions. So this would be 0, 0, 0, and then this top point should also be 0. Now, Roman 2, it says, what should be C so that the system would have no solution? So for this system to have no solution, then this left side should remain to be 0, 0, 0, and the right side should be non-zero. So the right side should be non-zero. So that means that for this system not to have a solution, C should not be equal to negative 6. C should not be equal to negative 6. So if C is not equal to negative 6, then this system would have no solution. For instance, if C is 2, you would see that the left side will be 0, 0, 0. 0 plus 0 plus 0 is equals to, if C is 2, then it will be 8. So, and this is not possible. This is not possible that 0 plus 0 plus 0 will be 8. So that means the system would have no solution. So what was the question? The question was, what condition should C satisfy? What condition should C satisfy so that the system has no solution? And I've said that for the system to have no solution, then C should not be equal to negative 6. And that is how you answer this question. So let's look at the next question. Now, this question is, we are doing it almost the same way we did the first question, the same reasoning, and we are given the system of linear equations here. We are told to use Gauss-Jordan reduction to put the augmented coefficient matrix to reduced row echelon form. The first one was not reduced row echelon form, it was just row echelon form. Now, so the question says that if you take that augmented matrix and reduce it to reduced row echelon form, the result should look like this. And when the result is like this, read for us the value of E, F, and G. This one has already been given to us as negative 1. Now, so let's just do this question and see. Let me load some space here so that we can do it here. Yes, this is enough. We can do it here. So let me write the augmented matrix. And the augmented matrix is negative 1, 5, 0, 0. Then negative 8. We have negative 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, 9, 2, 5, 5, 2, And then we have -3, -1, 3, 1, 3. And then lastly we have 7, 6, 5, 1, 30. So this one does not require a lot of reasoning. Just requires you to create this to be 1. And so to make this one 1, I will want to multiply this equation by -1, the first row. So multiply the first row by -1. So when you multiply the first row by -1, then you'll have 1, -5, 0, 0, 8. And here you have -2 because we've not touched the second row, so it remains the same way it was. And row 3 we've not touched it, so it remains the same way it was. And then the same thing to row 4, it was. Now, so we now want to use this to create a 0 here, a 0 here, and another 0 there. So to create a 0 in the second row, the new row 2 will be achieved by taking the current row 2 plus 2 row 1. So 2 times row 1 plus row 2. Then to get the new row 3, I'll take the current row 3 plus 3 row 1. And to get row 4, I'll check the current row 4 minus 7 row 1. So you know how to do this. So let's just see what we then get. So row 1 remains the way it is. I'll just do this, and then the rest I'll just be writing the results because you know how to do that. So multiply this by 2 and add it to this, you have a 0. This by 2 is -10. Added to this, you have -5. This times 2, and then add this, you have 5. And then you have a 2 here. This by 2 is 16. Added to this, you have 25. Now, this by 3, added to that, you have a 0. This by 3 is -15. Added to this, you have -16. Yes, that would be -16 because you just added -15 to -1. This by 3, and then add that, you have 3. Then you have 1. This by 3 will be 24. Add this, you have 27. Now come to the fourth row. Multiply by 7 and subtract from 7. You have a 0. Multiply by 7, you have -35. Subtract from this, you have 41. 7 times this, you have 0. Subtract from that, you have 5. Then you have 1. 7 times this, you have 56. Subtract from this, you have -26. Now we want a 1 in this position. That means we shall take row 2 to get the current row. The new row 2 shall take the current row 2 and multiply by 1 out of 5, -1 out of 5. So when that happens, then you would have the first row remains the way it is. The second row is the one we are multiplying by -1 out of 5 to get 0, 1, -1, -2 out of 5. And then we have 5. In fact, it's -5. The third row remains the way it is. And then this other row remains the way it is. So now we want to use this one created to achieve a 0 here a 0 here and a 0 here. So how do we achieve a 0 in the first row? So we need the first row. We'll take the current row 1 plus 5 row 2. Now what about row 3? We'll take the current row 3 plus 16 row 2. This is 16. Just write it properly. 16 row 2. What about row 4? I'll take the current row 4 minus 41 row 2. So what do we get when we do that? Let me just create some space here. Let me delete the rest. That I'm only left with the matrix that I'm using. I do not require this. I've already used it. So let me just delete this so that I'm only left with this other matrix, the one I'm using. So this is the matrix that I'm using. Now, so I want to do these row operations. Let me just write the result. Of course, you can do that. So the first row, when I do that, the first row I get 1, 0, negative 5, negative 2, negative 17. Then I'll get 0, 1, negative 1, negative 2 out of 5, and this other one was negative 5. Then this other one will give me 0, 0, negative 13, negative 27 out of 5, and this other one will give me negative 53. And this other row will be 0, 0, 46, negative, no, there is 87 out of 5, and this other one will be 179. Now, so I've achieved that. So what else do I want? I already have a 1 here and I've used it to create zeros. So I will now want a 1 here. So that means to get the current row 3, I'll take the current row 3 and multiply by negative 1 out of 30. And so when that happens, row 1 remains where it is. Row 2 remains the way it is. Now row 3 is the one you're multiplying by negative 1 out of 13, and that gives me 0, 0, 1. And this will be 27 out of 65. 27 out of 65, and this will be 53 out of 13. And then this other row remains where it is. This is 87 out of 5, and this is 176. Okay, let me again erase what I do not want. So I do not want this one because I've already used it. Now I've created this one. I want to use it to create 0 in this position, 0 in this position, and then 0 in this other position. So to get 0 in row 1, then the new row 1 will be obtained by taking the current row 1 plus 5 row 3. And then what about here? I want new row 2, and this will be obtained by just taking the current row 2 and add row 3 to it. What about this row 4? I'll take the current row 4 minus 46 row 3. Minus 46 row 3. So when that happens, what do we get? When that happens, let me write what we get. So I'm getting 1, 0, 0, 1 out of 13, and 44 out of 13. You can do that one later. Then this would be 1, no, 0, 1, 0, 1 out of 65. And this other one would be negative 12 out of 13. And this other one would be 0, 0, 1. But this is the one we're using. So this is 27 out of 65. 27 out of 65. And this other one is 3 out of 30. 3 out of 30. Then the last row, you would then get 0, 0, 0 there. Negative 1, 1, 1 out of 65. And this other one will be negative 1, 1, 1 out of 30. Now, so we already have achieved here 1. So we now want a 1 in this position. That means to get the current, get new row 4, I will take the current row 4 and multiply it by, because we wanted a 1 here, so I'll multiply that by negative 65 out of 1, 1. And so what does that give us? Now, so the first row remains the way it is. The first row remains the way it is. The second row remains where it is. The third row remains where it is. This is 27. 27, 27. Let me just erase that and write properly. So it will be 27 out of 65. And this other one is 53 out of 13. And then it's this fourth row that we multiply by negative of its reciprocal, which is 0, 0, 0, 1, 5. Now, I want to use this one to get a 0 here, a 0 here, and a 0 here, and that will be our final move. So let's just create some space. Delete what we do not require, what you've already used. But if you're using an exercise book, you're writing your answers in exercise book, and then you have enough space so that your work should be neat. Your work should be neat. Now, this is the matrix I want to use, so I should not delete it. I want to create a 0 in that position. So to get row 1, I want just to take the current row 1 and subtract 1 out of 13 of row 4. I also want row 2, I'll take the current row 2 and subtract 1 out of 65 of row 4. I also want row 3, I'll take the current row 3 minus 27 out of 65 of row 4. So what will that give me? Let me write what I get. 1, 0, 0, 0, 3, 0, 1, 0, negative 1. And this is 0, 0, 1, 0, 2. And this is 0, 0, 0, 1, 5. This is what the question wanted us to do. It wants us to reduce row echelon form, transform that matrix to reduced row echelon form and achieve this. And after achieving this, now read the value of A, B, no, E, F, and G. So E would be then 3, F would be 2, and G would be 5. And this is how this question was to be done. Now let's look at the next question. This question says, consider the following system of equations, and the system of equations is here. X plus AY is 1, AX plus Y is 1. For what value of A does the system have no solution? And that is the question I want us to answer. We do the same way we did an earlier question by first of all reducing the augmented matrix that can be extracted from here to row echelon form. Let's just get the augmented matrix. This is our augmented matrix. Reduce this to echelon form. So I want this one to use this one to create a 0 here. So that means to get the new row 2, I need the current row 2 minus A row 1. So when that happens, row 1 remains the way it is, and then multiply this by A and subtract from this to get a 0. This by A, subtract from this to get 1 minus A square. And this by A, subtract from this, you have 1 minus A. And this is the echelon form of this matrix. So now the question is, for what values of A does this system have no solution? For this system to have no solution, there are two things to consider here. We consider this part and this part. This part should be 0. This part should be 0. And this part should be non-zero. This part here should be non-zero. So when those two conditions are met, then the system would have no solution. So therefore, the first part here should be 0. So 1 minus A squared should be 0. In other words, A squared should be 1, or A should be plus or minus 1. A should be plus or minus 1. And what about this other part? This other part should be non-zero. And 1 minus A should be non-zero, should not be equal to 0. And when this happens, it means that A should be not be equal to, A should not be equal to 1. So then the first condition told us that A can be either 1 or negative 1, but the second condition have told us that A should not be 1, and therefore we are left with only one option for A. We are only left with one option for A, that for this system to have no solution, A should be negative 1. So this is the answer. That for this system to have no solution, A should be negative 1. And just check here. If A is negative 1, then the right side will be 2. The right side will be 2. And the left side here will be 0. So we can never have 0 plus 0 giving us 2. That means this system then has no solution if A is negative 1. Now, so just let me add some questions here for you to do them as homework. but we still have some questions. But just on this question, I've answered how to get the value of A, what the value of A should be if this system has no solution. What about what should be the value of A? Now this one you try it. What should be the value of A if this system would have infinitely many solutions? Many solutions. I don't know whether that is spelling, but you can check. So what would be value of A if it has to have the system is to have several solutions, infinitely many solutions? And two, what would be the value of A if this system is to have a unique solution? What would be the value of A if this system is to have a unique solution? And if this condition in Roman 2 is satisfied, if the condition in 2 is satisfied, solve the system. So what this question means is this, that find the value of A if this system was to have a unique solution. And after finding that value of A, now solve this. You replace this A with the value you've obtained and solve this. Solve this system, find the value of X and Y. So those are the questions I want you to again consider for this type of question. That we've already seen what A should be if this system is to have no solution. And now we'll ask you find the value of A if this system is to have infinitely many solutions. And also find the value of A if this system is to have a unique solution. So let's look at another question. Here is the question that is show that in the space R3, the vectors x, y, and z are linearly dependent. By finding the scalars AB such that ax plus by plus z is 0. And this is a very important question here. As you will see how I'll tackle it towards the end, you'll see how important this question is. Now, so let's just first of all define what we mean by linear dependence. I just want to remind you, you already know the definition. And we say that vectors, let me just use 3 vectors, vectors x, y, and z in V, where V is a vector space, are linearly dependent, if there exist scalars, A, B, and C, not all of them 0. Not all of them zeros, such that the linear combination, this linear combination A times x plus B times y plus C times z will be 0. And this is the definition of linear dependence of vectors. It's this definition that we want to use to solve this question. So let's just solve the question. The question is, show that these vectors are linearly dependent. So that means show that there exist some scalars, A, B, and 1. You can see it's a 1 here. This is 1. This is 1. This one has already been given. We've already been given the scalar here as 1. So show that there exist scalars a and b such that a times and x plus b times y plus something here times z should give us 0. So let's just begin by saying let a, b, and c be real numbers. So now take a times x plus b times y plus c times z and equate to 0. And when this happens, these are zeros. Let's just open the brackets. The first elements there will be a plus 4b plus 2c is 0. And the second one is 2a plus 5b plus c is 0. And this other one is 3a plus 6c, no 6b plus 0c is 0. Reduce this to echelon form. Reduce this to echelon form. So when we do that, the first equation remains. I don't want to continue using the augmented matrices. We can do without them. So let me just do without the augmented matrices, or so long as you know the steps. So you have this, and you want to use it to create a 0 here and a 0 here. That means to create a 0 in this position, you're taking equation 1 times 2 and subtracting from equation 2. So this times 2 separate from that, you have a 0. This by 2 is 8. Subtract from this, you have negative 3b. This by 2, you have 4. C. First, you subtract from this, you have negative 3c. And then this by 3 separate from that, you have 0. I also want a 0 in this position, and I'm using this 1a. So I need equation 3 minus 3 of equation 1. Equation 3 minus 3 of equation 1. So this times 3 is 3a from this, you have 0. This times 3 is 12b. Subtract from this, you have negative 6b. This by 3 of 6, c. Subtract from 0 here, negative 6b. Not the negative 6b. And this other will be 0. Now, of course, equation C, equation the second equation and the fourth equation are the same equation. If you were to factor out the common factor here. For instance, the common factor is 3. So divide through by 3, you have b plus c. And even this one, b plus c is 0 because the common factor for the third equation is 6. Now, so this is a plus 4b plus 2c is 0. This is b plus c is 0. This is also b plus c is 0. But now I want to use this to create a 0 here. So subtracting, in fact, let me just write this. So that now using this b to create a 0 here, I would have a plus 4b plus 2c is 0. And this other one will be b plus c is 0. And when I subtract the third equation minus the second equation, of 0 is 0. Now, the last row here tells me that this system has infinitely many solutions. And it's this type of questions that we let the free variable be t. So here the leading variable in the first equation is a, a leading variable. The second equation is b, and c is not a leading variable, so it's a free variable. So in most cases, we normally say that the free variable is a constant, any constant. But now the good thing in this question that the constant has been given to us is 1. So you can never let it be any constant. You can never let it be 2, you can never let it be 5, you can never let it be 6, and so on. Because we've already been told that z should be multiplied by 1. So from this I can see that x was multiplied by a constant a, y was multiplied by a constant b, but z was multiplied by a constant 1. So that means the question is limiting us to only one parameter, a, that t should be 1. That t should be 1. Somebody will even have put here 4. Somebody will even have put here 5. So if somebody puts here 5, it means that your t will be 5. So you look for the other parameters, the other a and b. Look for a and b, but now t here is 5. Somebody would also say that. But now, let me just emphasize this point, that if it was that we were not told that this should be 1, supposing it was to be c, then t would have been any value. One would have chosen t to be 1, another one would have chosen t to be 2, another one would have chosen t to be 5. So when t is 5, now get what a and b would be. Solving this equation, solving this going up, solving this going up. So if the question would have been left open, you would have let t be anything. But this question has not been left open. This question we've been told that t should be 1. And I hope you understood the explanation. So c is 1 from here. C is 1 because it was c that we were multiplying by z. But now the question tells us that c is 1. So if c is 1, now come to this equation and find b. So c is 1. Come here and find b. B would be -1. B would be -1. Now, b is -1. We proceeded with the first equation here. A plus 4b plus 2c. C is 1. So in fact, here is 2 times 1, which is 2. Here it's 4 times -1, -4. So -4 plus 2 would give us -2. So in fact, what we have here is a minus 2 is equal to 0, which means that a would be 2. A would be 2. And that is the only trick part in this question. That was the only trick part in this question. That is, the parameter here was given to us. So this is the answer. That a is 2, b is -1, and that is c is 1. But the question did not want c because it was given to us. It was given to us. So what I was saying is that if the question was left open, you would have chosen t to be anything. For instance, you can let t to be, you would have let even t to be 5. You would have let t to be 5 or anything. So if t is 5, and then that means c is 5, then that will then mean that b will be -5. So if b is -5, so we are talking of -20 at this point, and then 2 times 5, that will be 10. So -20 plus 10 will be -10 plus a. So it means that a will be 10. Or so would even have let, if the question was left open, somebody else would have even let t to be 2. So if t is 2, that means c is 2. Then b will be -2. B will be negative 2. And so what about A? This person will have proceeded to find A. So if B is negative 2 times 4 will be negative 8 in this position. And C is 2, so 2 times 2 will be 4. And so A. So this will be negative 4 is equals to 0. So A will be negative 4. The A will now be 4. A will be 4. So if this question was to be left open, we would have found so many solutions. And every person will have gotten his different or her different solution, not the same solution. But the question was not left open. It's so that we have people getting the same result for this type of question. Now let's look at the next question. The question says, let Px, Qx, and Rx be polynomials. Find A so that the set of these polynomials is linearly dependent. The good thing, we've already looked at a question involving linear dependence of vectors. So the definition still remains that for P, Q, and R to be linearly dependent, then we must obtain scalars. Let me say scalars x, y, z, or scalars w, n, m, such that one scalar times this p plus another scalar times this r plus another scalar times this r will give us 0. So solution, let m, n, and w be the scalars. So what we want is m times px, m times this is x squared plus 2x minus 3, n times the other polynomial, which is q, 2x squared minus 3x plus 4, and then w plus the other polynomial, which is ax squared minus 1, should give us 0. This is by the definition of linear dependence of vectors. Now let's just multiply and collect like terms and factor out the common terms. So when we do that, we'll get m as the first equation. I'm collecting those ones that have x squared. This will be mx squared, and this will be 2nx squared, and this will be w is equal to 0. So somebody may be asking where x squared went to. I've said I factored it out. Look at what happened. This will be mx squared, and this will be 2nx squared, and this will be aw x squared is equal to 0. So I just divided through by x squared. When you divide here by x squared, you get m. Divide here by x squared, you get 2n. Divide here by x squared, you get aw. Divide here by x squared, you have 0. That's what I wrote. Now let's now come to the ones that have an x. M times 2x, I'll get 2m. Remember that x will also cancel out. 2m. And then n times negative 3x, I'll get negative 3n. And then there is no x here, so this equals to 0. Then finally the constants are 3m negative. Then I have 4n. Then I have negative w is equals to 0. Now reduce this to echelon form. The first equation remains where it is. Multiply this equation 1 by 2 and subtract from equation 2. Sum this by 2 is 2m. Subtract from 2m, you have 0. This by 2 is 4n. Subtract from negative 3n, you have negative 7. This by 2 is 2aw. Subtract from 0, you have negative 2aw. Okay. Now, we want 0 here. That means I will multiply equation 1 by 3 and add the equation. So this by 3 is 3m plus this, I have a 0. This by 3, I have 6n. Added to this, you have 10n. This by 3, I have 3aw. Add to this, 3aw. 3aw added to w. Now, I want to use this. First of all, I want to make it 1. To make my work easy, I want to make it 1. So the first equation remains what it is. The second equation is the one I want to create a 1 here. So divide the entire equation by negative 7 to get n, 1n, and get plus 2 out of 7 aw is equals to 0. And this other equation remains what it is, 10n plus. In fact, at this point, you can factor w out to have 3a minus 1w is equals to 0. Now, having created the 1n here, I want to use it to create a 0 here. That means I want to multiply this equation by 10 and subtract from equation 2. So equation 1 remains the way it is. Equation 2 remains the way it is. 2 out of 7. aw is 0. Multiply this by 10. Subtract from this, you have 0. Multiply this by 10, you have 20 aw out of 7. And subtract from this. Let me just do it here. Just do it here. What I have is 3aw minus w. And I'm multiplying this by 10. And subtracting the result from this. So this would be 20 aw out of 7. So when I subtract, what do I get? The LCM there is 7. The LCM there is 7. This one has a denominator of 1. So I'm talking of 21 aw. The denominator is 1. So I'm talking of negative 7w. And the denominator is 7, so I'm talking of negative 20 aw. What is it when we simplify? When we simplify, 20 aw, 21 aw, those are like terms, and so it gives us aw out of 7. And this other one, just put the whole thing under that. This other one is just 7w. In fact, this one can be simplified to be aw out of 7 minus w. This one is not under the denominator. There's no denominator here. Or I can even write it as a out of 7 minus 1 w. And that's what I want to write here, in fact. A out of 7 minus 1 W is equals to 0. That's what I want to write. Let's go back to the question. The question says, let P and Q and R be polynomials. Find A so that this set of polynomials is linearly dependent. So that means, for linearly dependent means that the scalars must exist. The scalars must exist. And that is very important, especially the word that the scalars must exist is very important, because it's that word that once you know that, you go to the echelon matrix that we now have and look at the last row here and ask yourself, what should be A for us to have infinitely many solutions, or for us to have a solution, to this system? Then this left side should not be equal to 0. This left side should not, no, the left side should be 0. The left side should be 0 and the right side should be 0. But we have 0 is equals to 0. And as we've seen this type of question above, that whenever we had 0 is equals to 0, the system had infinitely many solutions. But if you have 0 on the left and then a constant and then 0 on the right, the system had no solution. System had no solution. So you only need to equate the left side so that we have the system having infinitely many solutions. So then we just rest a part that we do not require so that we complete the solution to this question. So I've left the part that I want to use. For this system to have infinitely many solutions, A out of 7 minus 1 should be 0. Or A out of 7 should be 1, which means that A should be 7. So if A is 7, so that we have 7 out of 7, which is 1 minus 1, that is 0, is equal to 0. Then this, if A is 7, then this polynomial should be linearly dependent. Somebody will have asked, what about, what would be A? What would be A if the polynomials, the above polynomials, were to be linearly independent? So if they were to be linearly independent, then it means that our scalars W, we were using it as scalars M, N, and W. They must each be 0. They must all of them be 0. W must be 0, N must be 0, and M must also be 0. If those scalars are each 0, then the polynomial should be linearly. So that one again would want to get a situation where W is 0. When we have W being 0, W is 0 if what is inside the bracket is not 0. If what is inside the bracket is not 0, then W is 0. So that means that if A out of 7 minus 1 is not equal to 0, if it's not equal to 0, and that means that A out of 7 should not be equal to 1, or that A should not be equal to 7. So if A is not equal to 7, then this polynomial should be linearly independent. For instance, if A is 14, then you note that this point would have 2 minus 1, which is 1. So I'll be talking of 1W is 0, which means W is 0. So if W is 0, come here and find N. If W is 0, then the whole of this will be 0. And if the whole of this is 0, then N is also 0. If N and W is 0, come the first equation. So this would be 0, this would be 0, and therefore M would be 0. That means that for these polynomials to be linearly independent, and you've seen how I have reasoned to arrive at this point, that for this to be linearly independent, then A should not be equal to 7. But if A is equal to 7, then these polynomials will be linearly dependent. And you can look at some examples so that you understand this type of reason. Let's look at the other question. Now, let's look at this other question. We've been told that we have 3 vectors here, and we are asked to find the value of C. That what should C not be equal to? What should C not be equal to if these 3 vectors were to form a basis of R? So again, we just need to remember the definition of basis. We say that when do we say that the 3 vectors form a basis of R? The vectors will form a basis of R. 1, if they are linearly independent, and 2, if they span R. Now, see the 3 vectors. If they happen to be linearly independent, then they will automatically span R3 and therefore form a basis. You see, they are already 3. If they happen to be linearly independent, then they will automatically span R. So that means we only need to check if they are linearly independent. What should C be? So that what should C not be equal so that they are linearly independent? And we know the definition of linear independence. We say that 3 vectors U, V, and W are linearly independent if they exist scalars ABC. If they exist scalars ABC, all of them 0, such that you will just write that definition. So 3 vectors U, V, and W are linearly independent if there exist scalars ABC, all of them 0s, such that the linear combination AU plus BV plus CW will give us 0. So these scalars should all be 0. But let's just do this question. We want to test for linear independence only because these are 3 vectors. If they happen to be linearly independent, then they automatically span. So we want to let X, Y, and Z be scalars. And that X multiplied by U plus Y multiplied by V plus Z multiplied by W will be 0. Or that 2X plus 3Y plus Z should be 0. This is 0x y minus z is 0, and this other one should be negative x plus 0y plus zc should be 0. Reduce this to echelon form. First of all, divide the first equation by 2. There is 0x plus 3 out of 2y plus z out of 2 is equal to 0. And this other equation remains the way it is. And this other equation also remains the way it is. Or this is zc This is Z, not 2Z. Now I want a 0 in this position. So what I will do, that the first equation remains the way it is. The second equation remains the way it is. And then add the first equation to the third equation. This will be 0 here. This will be 3 out of 2y. And this is z out of 2 added to this cz. So what I get there is I have, I'm factoring z out. Factoring z out. Let me just delete what I don't want so that I can complete the solution. I factored z out. Now you can see these equations. So now I want to use this y to create a 0 in that position. So the first equation remains what it is. This x plus 3 out of 2y plus z out of 2 is equals to 0. The second equation remains what it is. And now I'm multiplying this second equation by 3 out of 2 and subtracting from the third equation. So this gives me 0. So let me see. What I have here is a half of z plus 3z. And so I'm just subtracting 3 out of 2 of this. 3 out of 2 of z. So this first one, this second, this first and that third gives me z, 2z. This other one gives me z. So that means what I have here is 2 plus t if I factor z out. So the question is, what should c not be equal to? Now, if for this to be linearly independent, what we want is that this part should not be equal to 0. This part should not be equal to 0. So the part z plus c should not, it's 2. The part 2 plus c should not be equal to 0. Or that c should not be equal to negative 2. So if c is not equal to negative 2, then these vectors will be linearly independent, and therefore they form a basis. That is what the question wanted us to do. Let's look at the next question. Now, let's look at this other question. It tells us, Kenya invests a sum of 12,000 Kenya shillings in 2 bank accounts. These are supposed to be bank accounts. So 12,000 Kenya shillings is invested in 2 bank accounts. One of the bank accounts pays an interest of 10.5%, and another one pays an interest of 12%. So 2 years ago, this person got a total interest of 1335 Kenya. So how much was invested at each? So the solution to this, in fact, I should have said that use matrices, because the topic of today is about questions and answers in linear algebra. So this would be a very good question where we're using matrices because they're linear algebra. So we would then say let X Kenya shillings be invested at the interest 10.5%, and Y Kenya shillings be invested at 12% interest. So therefore, How much was invested? So X plus Y was invested. And this Y is what equals to 12,000. So this is our first equation. Because this person invested X in account, the first account, and Y in the second account, so that means the total amount invested is X plus Y. What about in terms of interest? If you invest X shillings and the interest is 10.5, so how much interest will X shillings, how much interest will X shillings earn? Will earn 0.105 interest. And Y was deposited, was the investor interest of 12. So how much interest will it earn? It will be 12Y out of 100, which is 0.01. So this is the interest that Y shillings will be earned, and this is the interest that X shillings will be earned. So the total interest therefore earned will be, total interest will be 0.105X plus 0.1. But this one is supposed to be what? Supposed to be 0.12, not 0.0. Supposed to be 0.1. Supposed to be 0.125. 0.125. So the total interest therefore will be 0.125. And this is what we are told, that it was 1,335. Now, so we want to reduce this to echelon form. The first equation remains the way it is, and multiply the first equation. Let me just create some space here for our working. Multiply the first equation by 0.105 and subtract the result from the second equation. So this by 0.105 from this, which is 0. This by 0.105 will give us that. Subtract that from 0.12. When I subtract, this will be 5y, and this will be 1, and this will be 0. So what I get there is 0.0151. Now multiply this by 0.105 and subtract the result from this. Get 7.5. Can do that with your calculator. Now, using this second equation, find the value of y. Divide both sides by 0.015. You get y to be 5,000. Then come to the first equation here. While there is y, write 5,000, and that means that x will be 7,000. What was the question? The question was, how much was invested at each rate? We've already said the rate 10.5% is x. So that means 5,000 was invested at 10.5%. 7,000, which one? No, not that. It is 7,000. 7,000. It is 7,000 that was invested at 10.5%. And then 5,000 was invested at 12%. And this is how this question is done. Remember to subscribe to my channel if you've not, so that whenever I load other lessons, you can automatically get them. Thank you for watching.